Welcome back. Let's continue with our lesson. We'll start with our concept map. As we said, it's divided into three. We are now going to look at properties of triangles. And the first part reminds us that the sum of angles of any triangle is 180. I wanted to stress the part any triangle. Irrespective of its shape, when you add the angles, angle A, angle B, and angle C, your outcome will always be 180 degrees. Look at that shape there. In triangle PQR, angle P is 65 and angle Q is 53 degrees. Determine the value of angle R. With the knowledge of what we have just said, that angles of a triangle will always be 180, we then say angle P plus angle Q plus angle R then must give us 180 degrees, because that is the sum of angles. Let me use shorthand here. Sum of angles of a triangle. Remember, when you write a statement, you need to support it with a reason, so that it shows that you are doing this because you know this is the reason why you are doing that. So now that we have been given angle P as 65 degrees plus angle Q as 53 degrees, and angle R is what we are looking for, which equals to 180 degrees. 65 plus 53 gives us 118. 118 degrees plus angle R, which equals to 180. And then to isolate R or remain with R alone on the left, we then have to use additive inverse of 118. So angle R will be 180 subtract 118 degrees. And therefore angle R equals to 62 degrees. That is our value of angle R. Let's look at conditions for two triangles to be congruent. The first one is three corresponding sides are equal. Let's look at two triangles freehandedly drawn. When we say corresponding sides, we are looking at, if we are looking at that side on triangle, let's say ABC and PQR, then we are also going to look, if we're looking at side AB, we are going to look on the next triangle PQR, we are going to look at side PQ, and then the bottom side, which would be BC, will be corresponding with QR, and then AC will then correspond with PR. So when we're looking at corresponding sides, they need to be equal, and then we then say side, side, side. So those three S's there stand for three sides that are corresponding and equal. Now let's look at the second reason for congruency, and that would be two corresponding sides and the included angle are equal. Look at the same free drawn triangle. Let's make the same PQR and ABC. And when we look at that now, we are saying if AB equals to PQ and BC equals to QR, then the angle between them, that angle B and angle Q, that angle between the two lines that are equal needs to be equal. That is why it says side, angle, side. The angle must be included. And it's not just an angle in the triangle, it's the one between the two sides that are said to be equal to one another. Let's look at the next condition, which is the third condition. Two corresponding angles and a corresponding side are equal. Two corresponding angles and a corresponding side are equal. Let's free draw again. Angle ABC, PQR. And we can use any letters. We don't necessarily have to be restricted to ABC and PQR. But then looking at two corresponding angles, if angle A equals to angle P and angle B equals to angle Q and a corresponding side in this case could be side AB, which is equal to side PQ. So we have two angles and a side that is corresponding with the one that we have in the next triangle, and therefore that makes those two corresponding angles and the corresponding side to be equal. So it's called angle side. And then the fourth one would be right angle, hypotenuse, and one other side are equal. Now in this case, the word hypotenuse speaks of a right-angled triangle. So you cannot have it in the triangle we've just drawn. So we need a differently shaped triangle that must have a right angle, because the word hypotenuse means the longest side of a right-angled triangle. So that would mean the side opposite the right angle. So that becomes the hypotenuse, and that becomes the hypotenuse in that one. Again, we'll call it APC and JKL, just for variety. And now we need to note that the first reason is a right angle. So this one, this, triangle APC has a right angle, angle B, and triangle JKL has a right angle, angle K. And then the hypotenuse, as we have identified, the side opposite the right angle, and it is the longest side of the triangle. And then one other side, so it can be side AB, which equals to side JK. Now we've got your three reasons: the right angle, the hypotenuse, and an additional side to be equal. Then those two triangles are said to be congruent. Now let's look at a question in this regard. Question A. In triangle ABC and triangle DEF, the marked sides are equal. Prove that triangle ABC is congruent to triangle DEF. How do we write that now? We've got two triangles, they have the markings, and now first part is to say in triangle ABC, because you need to show that these are the triangles we are dealing with, and triangle DEF. What do we know about those two triangles is that there's a single marking and a single marking. Therefore, I can say side AB equals to DE, and that is given by that marking there. And the next part would be there's a double marking there and a double marking. So side AC equals to side DF, and that is given. And then triple marking and a triple marking there. That means side CB is equal to side EF, and that is given. Again, you then notice I've got the three reasons, but then what are they? Are they angles? Are they sides? AB is a side, AC is a side, CB is a side. So therefore, I'm looking at sides of triangle, of the two triangles. Then I can safely say, therefore, triangle ABC is congruent to triangle DEF, and my reason then would be side, side, side. All right, let's look at the next one. The next question, ABCD is a parallelogram. Show that triangle ABD is congruent to triangle BCD and give reasons. Information that we know is ABCD is a parallelogram. Parallelogram means that the opposite sides are parallel. That's something that we get from just that word parallelogram. The opposite sides are parallel. Therefore, now let's look at the two triangles that they're talking about. Triangle ABD, and we are given one angle which is 27, and triangle BCD. All right, now let's go into our workout. How do we do that? We start with the triangles we're dealing with. In triangle ABD and triangle BCD, what do we know? We know that one, we have a marking and a marking on side AB. So AB equals to CD. Because of that marking, so we say we were given, it is given. Then we look at a side that is common on both triangles. ABD has side BD, that side there is common. It's on the top triangle and at the bottom triangle. Therefore, we say BD is common. And then we look at now, we have an angle of 27 degrees, and we look at the fact that line AB is parallel to line CD. Therefore, if this is 27 degrees, that angle there should also be 27 degrees. So we then say angle ABD, angle ABD is equal to angle BDC. And why is that? It's because AB is parallel to CD. And because of that, therefore, alternate angles are equal. And so now that we are looking at AB, which is a side, BD is a side, and angle ABD, which is an angle. Therefore, we can safely say, because of that, those three reasons, therefore triangle ABD is congruent to triangle BCD. And the reason for that is the 27 is included between the two sides, so it will be side angle side. That is the included angle. Okay, let's look at the next one. Now let's look at conditions of two triangles being similar. The first one is that the corresponding angles are equal. Now that means two triangles, let's free draw them again. Corresponding angles are equal. That means if angle A, triangle ABC, triangle DEF, if angle A is equal to angle D, those are corresponding angles. Then angle B is also equal to angle E, and angle C, I'll use three markings, will then be equal to angle F. That is when we say corresponding angles. Corresponding angles are equal. That is a condition of similarity. So all three angles of the triangle need to be equal to the corresponding angles of the next triangle. The next condition of similarity is corresponding sides, which are to be proportional. Now let's look at two triangles, ABC and PQR. Two triangles. And when we look at those two triangles, we then have side AB, the smallest side in the triangle, side AB, and side AB divided by the smallest side on the next triangle PQR, which is side PQ, and should be equal to the longest side BC divided by the longest side, which is QR, and should be equal to side AC on the ABC triangle divided by the side QPR on the PQR triangle. The reason for that is the answer that we find will give us a ratio, and that ratio must be equal on all three of those fractions. Therefore, we say these sides are in proportion. If the answer is not the same, then there are sides that are not in proportion. Therefore, those two triangles cannot be similar. They're only similar if the sides are in proportion and the ratio you find is the same for all three of those fractions. Okay. Let's look at a question in this regard. Use the markings on the diagram to determine that triangle JKL and triangle XYZ are similar. Let's look at the diagram that we're given, and you would notice that angle J and angle X are 70 degrees. So let's start with the identifying the triangles. In triangle JKL and triangle XYZ, what do we have? We have angle J equals to angle X in the next, which is that angle there, equals to that one, and angle K equals to angle Y. They are both equal to 63, equals to angle Y, and angle L equals to angle Z. And now that we have used the three reasons and all of them are angles, we are then able to say, therefore, triangle JKL, same triangle we're talking about, is now similar to triangle XYZ. And our reason for that is angle, angle, angle. Three angles that are equal. That is our reason. All right. Okay, let's move on to the next question in this regard. Prove that triangle ABC is similar to triangle EFG. And when I look at the markings, I notice that there is a relation between that side and that side. There is a relation between that side and that side. And there is a relationship as well in the sides that I have not marked. So in this case, I will then say, in triangle ABC and triangle EFG, what have I noticed is that side AC, if I divide it with side FG, AC being 24, FG being 8, 24 divided by 8, I get 3. Then I look at the other sides, side AB divided by the corresponding side EG, AB being equals to 15 and EG being equals to 5. I divide 15 divided by 5, also gives me 3. And the unmarked sides would be BC divided by EF, BC being 18, EF being 6, and that also gives me 3. Because I'm getting the same answer there, therefore I can safely say triangle ABC is similar to triangle EFG. And my reason for that would be the sides, corresponding sides, are proportional. The ratio is the same. Let's stop there for now. Let's go for an ad break. See you shortly.